All right, welcome to the Explainer. Today, we're going to talk about those few milliseconds that make all the difference. You know, the ones that happen right before your chatbot starts typing. We're going to look at the incredible engineering that makes large-scale AI feel, well, instant.
You know exactly what I'm talking about, right? You type in a big, complicated question, you hit enter, and there's just this tiny pause. It kind of feels like the AI is taking a deep breath before it answers. Well, it turns out that's not a bug. It's not a glitch. It's actually a clue to a really deep engineering problem at the core of how these things work.
So to really get why that pause happens, and more importantly, the super clever way engineers are fixing it, you have to understand something crucial. For every single answer it gives you, an LLM is actually doing two very different jobs. They're not the same at all.
Okay, so on one hand, you've got what's called the pre-fill phase. Think of this as the heavy lifting. It's where the model gobbles up your entire prompt all at once and does this huge, intense calculation to figure out what you're asking. It only happens once. Then, it immediately switches gears to the decode phase. This is totally different. It's like a machine gun, firing out the answer one word or token at a time. This part isn't about massive calculations. It's all about speed and hitting memory over and over and over again.
And here's the thing. This quote really gets to the heart of the problem. You've got these two totally different jobs, right? Prefill is a massive, compute-heavy sprint. Decode is a long, memory-intensive marathon. But for the longest time, we've been asking the same server to do both. That's kind of like asking an Olympic powerlifter to immediately run a marathon. I mean, they might be able to stumble through it, but it's just not what they're built for. It's super inefficient.
So what do you do about that? Well, a bunch of really smart engineers at Meta, working together with the vLLM open source community, looked at this and came up with a beautifully simple solution. They said, hey, why are we making one server be a jack of all trades and a master of none? Let's just let the specialists specialize.
The technical name for this is prefill/decode disaggregation. I know, it sounds super complicated, but the idea behind it is actually incredibly simple. Disaggregation just means to break apart. So you're literally just breaking apart the prefill and decode jobs and giving them to separate specialized servers.
Exactly. It's just common sense, right? If the jobs are different, give them to different workers. You let the powerlifter do the lifting, and you let the marathoner do the running. Simple as that.
So let's walk through how this actually works now. Your request comes in, and it first lands on a decode server. But a clever little thing called a proxy immediately forwards it over to a specialized prefill server. That server does all that initial heavy thinking, processes your prompt, and prepares what's called the KV cache. Think of that as the model's short-term memory for this specific conversation. Then it zips the very first word of the answer, along with that memory cache, right back to the decode server, which then takes over and streams the rest of the answer to you. Okay, so making that handoff happen smoothly and super fast across the network, that's the tricky part. It takes a few key pieces of architecture all working together perfectly.
Basically, you've got three core components making this all happen. There's a service proxy, which is kind of like the project manager. And then you have two KV connectors, a Python one and a C++ one, that do all the actual data moving.
Let's start with that service proxy. Seriously, the best way to think about it is as a really smart traffic cop. It's constantly watching all the requests coming in and all the prefill servers it has available. It doesn't just send your request to any old server. It sends it to the one that's least busy, or even better, one that might already have some of your data cached from a previous turn in the conversation.
And then you've got this awesome duo, the connectors. They really do work as a team. The Python connector is like the brains of the operation, the high-level manager. It's integrated with the whole vLLM system and makes sure all the operations happen in the right order, no conflicts. But moving all that data around is the grunt work, right? So it offloads that heavy lifting to the C++ connector. That thing is a low-level beast, an engine built for one thing, pure speed. It handles all the intense data transfer in the background, so the main model never even slows down.
Okay, so that's a lot of clever engineering. But here's the billion-dollar question. Does it actually work? Does splitting everything up really make things faster? Well, let me tell you, the results are pretty amazing. Before we look at the numbers, you gotta know how they measure the stuff. There are two main things they look at. First is time to first token, or TTFT. That's literally that initial pause we've been talking about. How fast does that first word show up? The other one is time to iterative token, or TTIT. That's the little gap between all the other words as they stream in. For a good experience, you want both of those numbers to be super low and super consistent.
And just look at this throughput gain. When they tested it, the new disaggregated system could handle 35% more requests every single second. So what does that mean in the real world? It means you can serve way more users at the same time without the whole system bogging down. That's a massive, massive jump in efficiency.
And it gets even better. For the same amount of traffic, the new system cut latency by 30%. What this chart is really showing you is how much smoother the experience feels. You get less of that jittery, stuttering text. The words just flow out consistently. For you, the user, it just feels way more natural and responsive.
But here's the thing, this huge performance boost wasn't just from the big idea of splitting the servers. It was also about a whole bunch of smaller but super clever optimizations that they layered on top to squeeze out every possible millisecond of speed.
Check out some of these tweaks. For example, they realized sending lots of tiny data packets was inefficient, so they started sending larger blocks. Boom, less overhead. They found a redundant calculation that was happening on the decode server and just turned it off. That stabilized the text streaming. And this one's really cool, sticky routing. It makes sure that if you're in a conversation, all your follow-up questions go to the same prefill server, which led to a 40 to 50% cache hit rate. That is huge.
And they didn't stop there. They programmed in some really smart software tricks. Like, the system is so fast that it sends you the first token while it's already working on the second one in the background. All the data loading, all the compute, it's all happening in parallel. The main GPU is never just sitting there waiting for data. It's a masterclass in keeping the machine busy and efficient.
And what's so exciting is that they are not even close to being done. This is just the beginning. The teams working on this are already planning the next steps to shave off even more milliseconds.
I mean, look at this roadmap. Right now, it's all about fine-tuning for the current generation of GPUs. Next up, they're working on making data transfers even smarter. Like, what if you only had to send the new information, not the whole cache every time? Then they're looking at bleeding-edge networking tech like RDMA to make the connection between servers practically instant. And down the line, they'll be building optimizations for chips that aren't even out yet. It's a constant push forward.
You know, maybe the coolest part of this whole thing is where all this work is going. It's not being kept secret in a lab somewhere. All of these battle-tested, production-ready improvements are being given right back to the open-source vLLM project. That means the entire AI community gets to benefit and build on top of this.
So at the end of the day, this isn't just about shaving off milliseconds for fun. This relentless obsession with speed is about changing how we interact with AI. As that little pause, that speed bump we started with, gets smaller and smaller and eventually disappears, it unlocks the possibility of truly real-time fluid conversations. And that makes you think, doesn't it? What new kinds of interactions, what new ideas become possible when there's no delay at all?